You are in Mandalay EF right now, getting ready to listen to Matthew Graber speak about abusing Windows management instrumentation to build a persistent, asynchronous, and fileless backdoor. As usual, please make sure that your phones are silenced. We don't want to hear your ringtones. This is Matthew's show. So, Matthew?
Thank you. All right. Thanks. All right, so I'm sure many of you are already familiar with WMI, otherwise you probably wouldn't be here. WMI is really an amazing technology, super old school, been around forever. It's really powerful for administrators, and consequently, it's really powerful for attackers and also defenders, and I'll touch on the defensive side briefly at the end. All right, but we're here to talk primarily about offense. All right, so some things you may not be aware of. Attackers are abusing WMI in the wild. Attacks go back as far as 2010, at least as far as I'm aware of. Going back to 2010 is like the first publicly documented case of malicious WMI in use. Okay. Some of you may not be that familiar with WMI. In that case, I'll be going over some of the basics. All right. And you may not know how to prevent and detect such attacks. Later on, I'll get into some pretty cool techniques, how you can use WMI against WMI attacks itself, as well as some additional mitigations. All right. Now, you may only be aware of its malicious capabilities as described in public reports. So I highlight this because you only know what you know. So I plan on describing some theoretical attack vectors, as well as some additional WMI attacks that we at Mandiant and FireEye have seen in the wild that you may not be aware of yet. All right. With that said, I'm a malware reverse engineer at FireEye. I'm on our FireEye Labs advanced reverse engineering team. We've got a really bright group of guys that we work with. And we also just released our second Flare-On challenge. So check that out on at flareon.com. All right. I've spoken at various conferences, and as you may or may not be aware, I am a huge PowerShell fanboy, all right? Okay, so sophisticated attackers are living off the land, and I want to give a shout out to my buddy Chris Campbell, who kind of coined that phrase in this context, all right? So basically, any tool that's useful to a sysadmin is going to be extremely useful to an attacker as well. Right, so I would like to think that this is probably like a huge security gap for those security vendors out there who are focusing really heavily on scripts or binaries being dropped to disk. This is entirely unnecessary. As you'll see, WMI is just one means to execute your malware without dropping anything to disk. Of course, there's PowerShell as well, which enables you to execute really any conceivable payload that you would be able to write in C in user mode entirely in memory using PowerShell. All right. Now, I like to say this a lot, all right? If you can dream it, all right, from like an offensive researcher's perspective, it's probably already been done, right? So I said that the public reports of WMI attacks go back to 2010, right? Well, WMI has been around since like the dawn of time, like since Windows 98, right? So who's to say that that is the first instance of WMI attacks, all right? So there's probably people in this audience, people not present here, who are already experts on WMI, but they're probably not the ones who are speaking at conferences, all right? So, a little outline here. I'm going to cover the basics, some of the WMI utilities, so how you go about actually interfacing with this technology. One of those ways is using WMI query language, WQL. It's very simple SQL-like syntax for working with this stuff. And then I'll cover WMI eventing and remote WMI. These are like what I consider to be the killer features of WMI. All right. I'll briefly go into how WMI has been used by attackers in the past, as well as I'll cover some like theoretical attack vectors that I personally haven't seen used in the wild. I'll also touch upon providers. Providers are DLL DLLs or device drivers that really provide WMI all of its functionality under the hood. I'll wrap this up with like pure proof of concept WMI backdoor that I developed. All it is a PowerShell script. It's just an installer, but it doesn't require that the target system have PowerShell installed on it. So you theoretically could install this on a Windows 98 machine. And then I'll cover detection mechanisms and attack mitigations. All right, the basics. So WMI, Windows Management Instrumentation, it's been around forever, like literally since Windows 98 and NT4. All right, so from your Windows 10 machine with PowerShell on it, you could easily run payloads on a Windows 98 or NT4 system. The technology fundamentally has not changed. System administrators have been aware of this technology forever. I think it was like just recently that this has really come to the attention of security researchers and pen testers and red teams. All right, it can be used to do some really useful things. Okay, we can read from the registry, write to the registry, examine the file system, drop files, read files. All right, you can also execute commands. All right, this is used pretty heavily. WMI is used as a technique to perform lateral movement and code execution, primarily using the Win32 process create method. And you can also subscribe to events. And these events persist across reboots and don't drop any files to disk other than a single file which AV would never touch. And what is that file? It's objects.data in System32 WBEM repository. All right, this is the WMI repository where all persistent WMI objects, as well as namespace definitions, class definitions, everything is stored in here. All right, this is a completely undocumented format until tomorrow when we're going to be, so myself and my colleagues, Claudio and Willie, are going to be releasing a white paper that's going to come out on the FireEye blog that covers how to parse all this out. And also we're going to be speaking at DEF CON about using WMI for defense and performing forensics on this objects.data file. All right. So Willie and Claudio did some really amazing work reversing this stuff, and their forensic parsers are available online right now. So please check those out. All right. The WMI settings, just for your general knowledge, these are stored in the Microsoft WBEM registry key. You can also access them via the Win32_WMI setting class instance. All right, so this is one of the things of interest in here is the auto recover MOFs entry. So one previously popular persistence technique was to drop a MOF file onto a victim system, run mofcomp.exe, and then that would be consumed, and then you would have your persistence mechanism. So MOFs are kind of cool. They're not necessary in my opinion, but you can drop MOFs if you want to persist your WMI payloads beyond WMI repository corruption. So I don't know why you'd want to do that necessarily. It does create additional forensic artifacts, but it's something to be aware of that you as a defender should be looking at. All right, so how do we interact with this stuff? Yay, PowerShell. PowerShell is like the best utility out there for interacting with WMI. This is a PowerShell version 3 window that you're looking at. And what you see here is a grouping of both WMI commandlets and SIM commandlets. There's not really too much of a difference between the two. Only the WMI commandlets are like the legacy ones. So these are present going all the way back to PowerShell 1. The SIM commandlets were introduced in version 3 and above, and they do the same exact thing as the WMI commandlets, only they talk both protocols, which I'll get into briefly. So they're both DCOM and WinRM, which is going to be present on more modern Windows OSs. All right, some additional utilities you should be aware of. I'm sure many of you are familiar with wimic.exe. Okay, this is a really powerful utility. It does have some limitations. PowerShell, in my opinion, is always going to be the best way to work with this stuff. There's WinRM. So if the WinRM, so I'm going to use like the terms WinRM and PowerShell remoting interchangeably. If that service is listening and say like application whitelisting for whatever reason like blocks PowerShell, you could run WinRM to enumerate WMI object instances. You could execute WMI methods. It's a pretty powerful utility if that's what you have to fall back to. WBM test is really cool. It's like a really crappy like GUI interface. It serves as like a test utility. I've run in various assessments in the past, I've run into cases where like I couldn't run wimic.exe or PowerShell.exe. So this was a good fallback. There's pretty much nothing that you can't do with regards to WMI via this tool. You just have to get over the crappy interface. There's a bunch of Linux utilities as well. WMIC will accept any WMI query. WMIS is basically like a wrapper for the Win32 process create method, for like lateral movement and code execution. And then a good buddy of mine, Skip Duckwall, patched WMIS so that it will accept NTLM hashes, which is pretty cool. There's some additional interfaces as well, VBScript, JScript. If you're gonna incorporate this into your code, you have some COM APIs, as well as some pretty full-featured .NET classes. All right, so if we're gonna interact with this stuff over the network, which is pretty amazing that we can do this because on every system, the WMI service is already listening. All right, so the protocol that's been around forever that is still likely listening on every single one of your systems is DCOM, all right, TCP port 135. So port 135 is used to establish an initial connection, and then all subsequent data is passed via a secondary TCP port number specified in the range that you see here in this registry key. You can actually use DCOM config or just modify the registry entry directly to have it only use a single port so that you can maybe make it like a little more firewall friendly. All right. So here's an example of me using, I'm calling getWMI object, and I want to enumerate processes on this remote system. So it's really simple. You just provide the host name or IP address, the credential. So you provide like the domain or the host name and the username. It'll prompt you for credentials, and then you get a nice process listing. All right, the other protocol, this like modern protocol for like, it's called PowerShell remoting or WinRM. It is a SOAP-based protocol. It's encrypted by default. So like if you were to install like Server 2012 R2, I believe, like in server core mode, this would be the only port listening. So you would have port 5985 listening. There's a really handy PowerShell commandlet. It's called test-wsman. It's like a really convenient port scanner that doesn't require authentication. So like you could sweep the enterprise to see what machines are listening on this handy protocol. Also, you can configure all of the settings within PowerShell using the WSMan PS drive. So another reason PowerShell is really cool is because of the concept of PS drives, right? So like you could do an ls on the file system, right? And you would get what you expect, a directory and file listing. Well, you can also do an ls on the registry, right? So ls hklm:/. Like that's really cool. You can also use that to look through like the certificate store. So just one of many reasons PowerShell is really, really handy. All right, eventing. This is that killer feature that attackers love to take advantage of. All right, so using WMI, we can trigger off nearly any conceivable event in the operating system. And the way that's achieved is, in order to register a WMI event, you need three things, all right? An event filter, so this is the action that you want to trigger off of. So this will take the form of a WQL query. The consumer, so upon firing that event, what are you gonna do, right? So Microsoft provides 5 standard event consumers, 2 of which are very useful for attackers. And then you just bind the 2 of those together, the trigger and then the payload, by using a filter to consumer binding. All right? There's 2 ways in which these events can be executed. You can run them locally in just a host process. For example, you can call like register-WMI event to run it locally in the PowerShell process. The real power out of this is when you register a permanent WMI event consumer. So it persists across reboots and it also executes as system. All right, there's 2 types of event classes, intrinsic and extrinsic events. So I'm listing out all of the intrinsic events here. So WMI classes are organized hierarchically by namespaces. So one of the most popular namespaces is root simv2. And when you're scripting with WMI, this is the default namespace that's used. So there's some really useful classes in there for both offense and defense. So within every one of those classes, you have these special system classes, these events, these intrinsic events. And you can be really flexible with how you create your event filters. So for example, if you wanted to enumerate running processes, every time a new process is created, it creates an instance of a win32_process object. So you might tap into the instance creation event and just filter out instances of those win32 process objects. There's some malware I'll be discussing shortly that both creates and modifies namespaces, and it uses this as a C2 channel. There's another attack group that is creating and modifying WMI classes and using that as a pretty cool command and control channel as well. So in that case, you would have the class creation event fire. So if you were registered to these types of events, then you could gain some insight. So as a defender, you might be able to detect these things. As an attacker, you should be mindful that these events are going to trigger upon performing your malicious action. All right. Now there's these specialized events called extrinsic events. There aren't that many of them, but they're highly performant, and you don't have to specify like a polling interval. So these events fire immediately upon each one of them occurring. So there's some pretty interesting events that I've listed here, both for attackers and defenders. All right, so win32 process start trace. This fires immediately upon any process starting. So imagine there was some process, like executable name that you were targeting, I don't know, like procexp.exe, and upon triggering that, like you would just go and kill that process. You could really get creative with these here. From a defense perspective, imagine using triggering off a Win32 module load trace. All right, this is fired upon any DLL, exe, device driver being loaded. Okay. Registry key change event, registry value change event. These should be pretty self-explanatory. Very powerful. All right, so WMI event filters. Again, I said the events that you want to trigger off of, these all take the form of a WQL, a WMI query language query. And so here are 2 examples of using these events, so using an intrinsic and extrinsic query. All right, so let's look at this first one here, this intrinsic query. So at a high level, what this is going to trigger off of is the creation or modification of any file that has a doc or docx extension. All right, and the way we kind of interpret this is we're interested in any event that fires that is an instance creation event or an instance modification event of class type sim data file. All right, so whenever any directory or file is created or modified, it fires off these events. Now we have to be a little more abstract in forming our query since we want to capture both creation and modification events, and both of those classes derive from the instance operation event. So that ultimately is what we want to trigger off of. And then once that triggers, you can look at the target instance property, and those target instance properties are going to take the form of that sim data file. So you can just inspect the extension field and match it against the file extensions that you're interested in targeting. And here we have to specify a polling interval, right? So one caveat with this is, say you have a file that's created and deleted within that 30-second interval, you're not going to catch it, unfortunately. All right, so an extrinsic query, this is a pretty interesting one. This will fire immediately upon a volume change event. So if you were to look up this object in MSDN, you would see that event type 2 is a removable drive. So this would fire upon insertion of removable media. All right. So once you have the WQL query that you formed to target the event that you're interested in triggering, you want to do something upon that triggering, right? So the two event consumers that attackers are very fond of are active script event consumer. All right, you can embed any Windows script host language as a payload in this consumer. So a Windows script host language would be VBScript or JScript. All right, so you can have those payloads in line, and nothing would be present on disk aside from being present in that objects.data file, the WMI repository. You can also execute anything at the command line using the command line event consumer. So imagine someone inserts removable media and you want to execute some payload, right? So imagine you could execute, say, PowerShell.exe-encoded command, and then you'd have, I don't know, maybe like a drive infection payload that would drop something of interest onto that USB stick. All right. The other standard event consumers are going to be of particular interest to defenders, right? So we can append to a log file, create an event log entry, send an email. All right. And both of these are present in the SimV2 and default namespaces. All right. So let's tear into some previous malware that has become public. So the first time I ever heard of WMI, I'm not a sysadmin by trade, so I really had no idea what WMI was until around 2010 when I was reading up on all the articles about Stuxnet. And this wasn't really mentioned too much, but one of the exploits that Stuxnet took advantage of, or vulnerabilities that Stuxnet took advantage of, was MS-10-061, the printer spooler vulnerability, which basically enabled the attacker to write an arbitrary file to the file system. So just imagine, if you could drop any file to the file system in order to gain code execution, how might you go about doing that? So what the attacker did was they dropped one of those moth files, which had embedded within it a permanent WMI event subscription. So they dropped it into a very specific directory, and then there was basically a watchdog process that would monitor that directory, and if it detected that there was a new moth file present in there, it would go ahead and consume it, and you would automatically persist and gain code execution in the system context. So Microsoft fixed this exploit primitive so that that watchdog process will no longer just happily go consume any moth file present in that directory. All right, then there was Ghost. This was commodity malware. There was a really good write-up on this that Trend Micro did a while back. So what this malware did was it used a WQL query to the one that you saw previously that monitored for the creation or modification of any files. Only rather, instead of targeting a specific extension, it targeted a specific directory, specifically the recent folder. So any new recent documents, it would just exfil those via an ActiveX control. So it basically used the IE com object to upload the contents of those documents to some command and control server. All right, so the payload itself, that ActiveX control was embedded within a VBScript payload via one of those ActiveScript event consumers. All right, and released not too long ago was a really cool tool called WMI shell. So this was the first case where I saw WMI used as like a pure C2 channel. All right, so the mechanism by which it used it as a C2 channel was it created WMI namespaces dynamically or modified them. So what that would allow you to do is, like, you could just stuff a payload in as the name of a WMI namespace, and then you could do something like call the create method in the Win32 process class to consume that data, like say base64 decode it and execute like some PowerShell command that was embedded within it, right? And then what you could also do is take the result of that malicious PowerShell command, write the output to say like another WMI namespace, and then read that back remotely, say like using the get WMI object commandlet, right? So you're using WMI as a pure C2 channel, which is pretty cool. All right. So WMI is extremely powerful, right? So, but from an attacker's perspective, like there's really nothing you can't do from like a post-exploitation perspective. So look at every phase of an attack, and you can accomplish that with WMI, given that you have proper credentials to do so. All right, so if you were to, sorry, I will get to reconnaissance briefly. So benefits to an attacker is, so the service, it's running on every single system. Again, going back to like Windows 98 and NT4, all right, it's running as system. Every machine has its is listening on like this DCOM port or like WinRM, unless you've explicitly disabled this service. It is relatively esoteric at this point. Hopefully after this talk it won't be. So defenders like still aren't really aware of the repercussions of attackers leveraging WMI. All right, nothing touches disk unless you want it to. The only exception being when you register like a permanent WMI event subscription, it's only going to be, that payload will only be present in objects.data. And AV will not touch that, right? For the same reason that AV would never flag on like ntds.dit, right? If you store like some payload in some like Active Directory property, AV's not going to touch this file, all right? Now, if you were to go about performing some reconnaissance as an attacker, these are some of the WMI objects that you might be interested in. In reality, I did a scan of this Windows 7 machine that I'm presenting from, and there's actually just under 8,000 WMI classes available to you. These are just some of the highlights that I'm presenting here. So you can get detailed host OS information using these WMI objects. You can perform registry operations, read from and write to the registry. So like you could use that std-regprov WMI provider, say as a persistence mechanism, right? Like you could write PowerShell.exe-encoded command and then have like your PowerShell stager. You could write that into the run key, right? Automatic persistence using WMI. You can enumerate processes, services. You can start, stop services, read the event logs, enumerate all of the patches on a system, enumerate shares, create shares, delete shares. There's very little that you can't do here. All right. So this is extremely powerful, and attackers are already kind of aware of this. I've seen them using wimic.exe pretty often. So here's like the PowerShell variant of wimic.exe for lateral movement. So I'm just calling invoke WMI method, and within the Win32 process class, there's the static create method. All right, and this will just go execute any command line program that you provide it, and I'm doing so remotely. All right, so just imagine replacing notepad.exe with PowerShell.exe-encoded command. Insert malicious payload here. All right, here's an example of WMI persistence. So recall what I said the three requirements were in order to persist. You need one of those event filters, event consumers, and the filter to consumer binding. So this is I found in the wild in the CDaddy malware family, which is our internal family name. I think like the public name is CDuke. So there's some pretty good write-ups on this. This is pretty basic. It's broken down as follows. So you have this long query, which basically states, fire this shortly after system startup. So it's just going to wait between 200 and 320 seconds, and then it's going to fire the event consumer, which is just that command line event consumer, which just executes in this fictitious case evil.exe. All right, so not very sophisticated. So this assumes that another binary was dropped to disk. So this isn't super stealthy in my mind, but it's illustrative of how you might go about like practically using WMI as a persistence mechanism in very few lines of code. All right, so I didn't realize this until recently when I was pulled into this one case that we were investigating, and we've got some awesome incident responders at Mandiant who had been investigating APT29. So you may be aware that FireEye released a report on the malware family called HammerToss, and we attributed this to APT29. All right, what that paper did not discuss was the WMI attack vector that they used. So here's a small example of what APT29 was doing. All right, they were creating custom WMI classes dynamically and adding properties to those classes and stuffing payloads in them. So really this was very similar to like what the WMI shell tool does, only instead of creating and modifying namespaces, the attacker was just creating and modifying classes on the fly. So I didn't even realize that you could do this. I thought that you would have to drop a MOF file to create these classes dynamically, when it turns out you can just use some of these really handy .NET classes to achieve that for you. So this is an example of me doing that locally. Now the attacker was doing this remotely. So you can just extend this a little bit to create and modify classes remotely. So imagine just stuffing your payload in there, executing a malicious PowerShell command, saving the output to another class property, and then reading that back using WMI as a pure C2 channel. All right. And with that, so as I said before, WMI shell was using those namespaces. APT29 were using dynamically created classes. You could also conceivably use the registry as a means of like staging your exfil. So using that std regprov provider, like you can just write arbitrary data to any registry key and value that you create, and then you can execute that embedded payload, say, write the result of that command to another registry value, and then read that back remotely. So these were attackers and researchers had already demonstrated the namespace and class creation. I just kind of thought of like maybe using the registry. I'm sure there's other means of like pushing and pulling arbitrary data using WMI as well. If you think of any clever uses of WMI as a C2 channel, let me know. I would be curious to know. All right, so I'm going to demonstrate an example here of using WMI to push a payload onto a victim system. In this case, we're going to plant some sensitive evidence on our victim here. So in the first block, I'm just specifying the file name locally on my system that I want to drop onto the remote machine. Okay, so I'm going to read it in as a byte array, convert it to a base64 string, and then I'm going to set up my remote WMI connection. And what I'm going to do after that is create the win32_evil class and create an evil property that is attached to that class. And then I'm going to stuff the base64 encoded content of the evidence that I want to plant on the victim machine into that property. Okay? So technically the contents of the file are present on that system, but they're only present base64 encoded within objects.data, right, the WMI repository. So if we want to actually do something with that data that's stuffed in there, we might do something like this. So we're going to execute some PowerShell on the remote system, and we're going to read directly from the Win32 evil property, which has that base64 encoded evidence. And then we'll drop it to C fighterjet specs.png, whatever. So the way we go about executing that is by calling the Win32 process create method that you should all be familiar with by now. Okay? And then you can also remotely confirm that the file was dropped by calling getWMI object to see if there's an instance of the sim data file present on that system that has that exact file name. All right. So in the previous example, we just dropped a file to disk, so I called that like the push attack. Now in this case, this is very similar to like what APT29 was doing, only they were using custom classes like I used in the previous example. Here I'm just going to use the registry as a means of pushing a payload and then reading the results of that payload back using the registry. All right. So I provide the credentials to the target system, and I create the in HKLM software evil key, that registry key, and then I'm going to delete the value of the present in result, because I'm going to populate that in a second. All right, so just my fictitious payload here is I'm just going to get a process listing for LSAS. All right. Kind of a silly payload, but just it's good at demonstrating the point here. So when you call get process or anything for that matter in PowerShell, it returns objects. I really like working with objects, so I chose to preserve my objects here by serializing them using the PS serializer class. So that just takes the contents of the object, converts it to XML, and then I'll base64 encode it, save it in that registry key, pull it back, base64 decode it. So I pull it back using that stdregprov provider. And then, so yeah, base64 decode it, and then call deserialize on it, and then I have this nice, beautiful PowerShell object that looks as if it had been executed locally, only it was the result of that payload running on a remote system that ultimately, like, I managed to return this like proper PowerShell object. All right. So one other like theoretical attack that you might be able to perform is say you want to avoid calling the Win32 process create method, which is susceptible to like process and command line auditing, right? Because if you're executing like PowerShell.exe-encoded command, this might be logged and reported. So if you wanted to be like extra stealthy, conceivably what you could do is create a temporary permanent WMI event subscription. So the way you would do that is you would create a ActiveScript event consumer consisting of your payload. And so normally this would like persist across reboots, but then part of your payload would be like the trigger for it would be say like an interval timer instruction. So you push the payload down, this timer instruction fires after say 1 minute. And then part of your payload is, so it executes all the malicious stuff first, and then it deletes itself. So it deletes its corresponding event filter, event consumer, and filter to consumer binding. So that's kind of a clean, like a little more stealthy method, in my opinion, of getting code execution on a remote system if you know that, say, command line auditing may be present. So the only thing that a defender might see would be the execution of scrcons.exe-embedding. So from an attacker's perspective, it's a little bit more stealthy because you wouldn't see something like in the previous cases where I was calling PowerShell.exe and executing some like plain text command. You wouldn't see any of this. And then if you were to perform offline WMI forensics later on, this payload wouldn't be present in objects.data. All right. So I've talked about MAW files a little bit, but the reason I don't expand upon them really is that I don't feel that they're necessary from an attacker's perspective. I think they just add unnecessary artifacts that would end up getting you caught. Really, the only advantage, in my opinion, and please tell me if I'm wrong later on, the only advantage from an attacker's perspective is that these things will persist if you specify the pragma auto recover in your MAW file. They'll be consumed again like after WMI corruption, which probably isn't going to happen anyway. So moving on. All right, briefly, WMI providers, these are kind of like the back end to WMI. So these provide the WMI subsystem with everything they need to provide the objects that you're interested in, right? So take win32_process. If you're enumerating all processes, there's some code on the system that has to enumerate running processes and then parse out that data and present it to you in such a manner that that you can read it, say, like in PowerShell or wimic.exe properly. So that's what these providers do. Most of them are registered in the registry using, so each provider has a respective like Win32 provider class instance, and one of the properties is a GUID. So if you just take that GUID and then look it up in the registry, there would be a DLL, and that's the actual code that backs that provider. You can also have kernel drivers act as providers as well, and those are all stored in the root WMI namespace. All right, so what might one of these providers look like? Well, there are some legitimate providers from third parties. One of them being, well, legitimate is kind of a subjective term here. On my Lenovo ThinkPad laptop, I have installed this this device driver WMI provider so you can use it to remotely get like BIOS settings and remotely set BIOS settings. So, sure, that might be legitimate. Now, so I was talking with my colleagues, Willie and Claudio, and Willie brought up a while ago just that, theoretically, like, why not just create a malicious WMI provider, right? Because then you could maybe create some like interesting custom like WMI objects, implement your own methods, right? So like the Win32 process create method is really nice for attackers. Why can't we extend that? Right, so I reached out to some buddies on Twitter, and Casey Smith and Jared Atkinson. These guys are awesome. So they banged out some proof of concept, actual like legitimate malicious WMI providers, like that very night when I gave them all of these requirements. So the first one that Casey did was he created a shellcode runner implemented as a WMI provider. So if you were to take this WMI provider DLL, drop it onto the victim system, install it with install-util.exe, then you've got a means of executing shellcode either locally or remotely onto that victim machine, and that shellcode runs in the system context. Pretty cool. Jared, what he wanted to do was enumerate all active network connections, because in Windows 7 and below, you don't get any built-in classes that allow you to enumerate this stuff. So he did that, and he also allowed you to execute arbitrary PowerShell in the system context. All right. So I wanted to take some of these like theoretical attacks and extend them a little bit into the form of a pure WMI backdoor. So you can get this online now. All it requires is a PowerShell installer. It doesn't require that PowerShell be present on the system. All right. So yeah, again, PowerShell is not required, and it installs several permanent WMI events. All right, so it does a few things. You can implement your triggers, so you might want to fire off at a regular interval at a certain date time. You might want to target a certain process name, new or modified files, interactive logon, or drive insertion, all right? And then you bind that together with a respective action. So you could say, combine the file creation trigger with the file upload action, okay? Or drive insertion trigger with infect drive action. And then you register those together with the registered WMI backdoor command. All right, so here is a brief example of the generic backdoor that I implemented in this code. So what I'm doing here is I'm queuing up a few commands. All right, this is just a VB script like file dropper. So I'll queue that up in my backdoor. Next, I'm going to queue up a PowerShell file dropper, and instead of just executing like VB script directly, I'm going to save that into a WMI class property. All right, and then I'll queue up another command to execute something at the command line, in this case being PowerShell.exe -command, and then what the payload is going to do is pull that down from the WMI class, base64 decode it, and execute it. All right. There's a little bit more of this video, but in the interest of time, I want to move on to the next example, the file uploader. So I have my C2 server listening, all right, on the right side, and then on the left side, I will install my file uploader. And so whenever any file is created or modified, it's going to upload those contents to the command and control server. So I provide all the code for this WMI backdoor freely online. I'm not providing the C2 server itself, though. All right. I don't have much time left, so I want to maybe try to get away with this live demo here, the drive infection payload. All right. So I'm going to take this here, copy it into my victim. All right. And just to prove to you that nothing is on this USB stick, let's hope it pops up here. All right. Sorry, not going to deal with this now, I guess. Demo fail. All right, so what it would have done if my VM did recognize it is immediately upon insertion, it would have dropped my file. In this case, as you'll see in the code, it just drops the EICAR signature, which is supposed to flag antivirus immediately. I'm not really doing anything too subversive. Again, this is just a proof of concept that I wanted to demonstrate. Another thing that I was going to show is the process killer, where I would be targeting Process Explorer, and then anytime that opens, the payload would just automatically kill that. All right, so real briefly, some mitigations. You can enumerate WMI persistence remotely, all right? Using PowerShell as a great example. There are some existing utilities out there. Autoruns and Kanza are great for detecting this stuff after the fact. And I'm going to be discussing this in much more depth at DEF CON on Saturday with my colleagues. So WMI is actually a really awesome agentless host IDS. All right, so there's a ton of attacker actions that would take place that would fire off these WMI events. And so if you just subscribe to those events, then there's all kinds of things that you might be able to detect. For example, if an attacker creates like persistence via the registry or the start menu, there's a really handy WMI object, win32_startup command, an instance of that is created. So you could tap into that and detect attacker persistence, or registry or start menu persistence using just that mechanism. You could also use this to detect whenever permanent WMI event subscriptions are created, right? So you have a permanent WMI event subscription that detects permanent WMI event subscriptions. You can get really creative here. All right. Finally, some mitigations are you can just outright disable this service if you don't need to access it remotely. You can apply firewall rules to say block those decom ports. There are some great, pretty detailed event log entries. And then, as I said, you can have preventative permanent WMI event subscriptions. Lastly, you can also apply ACLs to all of the WMI namespaces. So you can prevent, like, for example, the Win32 process create method from being executed by applying ACLs properly. All right. Just a quick shout out to my buddies Will Schroeder and Justin Warner, who helped me out and came up with some pretty creative event filters. To my awesome coworkers who reversed the entire format and really opened up the field of WMI forensics, because there was no forensics capability prior to today at B-Sides when we presented the defensive and forensic side. All right, and lastly, to all defenders who are taking WMI seriously or hope to take WMI seriously after this talk. All right, I don't have time for questions, but thank you very much. I'll be just outside the door if any of you have any questions, so thank you.